Okay, thank you very much.
Okay, so Dr. Phil, I think you have the floor, even though it's 4 minutes to time. So whenever like you are ready, you can go.
Oh, okay. Okay, thank you.
Thank you.
Hi, Dr. Kwame. Dr. Kwame, we're
Okay,
having some
so
issue
please
here. I
let's
don't know if
try
you can.
to mute our mics. And as we said, instead of drawing us back every minute, if you have a question, just note it down, and the instructor will always give room for questioning so that we'll have a flow during the presentation. And then you'll also be able to enjoy the recorded version. Okay, so Phil, can you share your screen so that we see?
I think the sharing has been restricted. Only host can share, so I think I should be permitted to share.
Okay, Gideon, can you please make him a
I think
co-host?
he is co-host, right?
Yeah, but
Really?
he's not at the moment.
He's not sharing at the moment. Let me see. Just wait a minute. Yeah. You can try now. Let's see.
Okay. Is this okay? Try again.
It is sharing, right?
No, it's
Try
only
it.
showing me when I click on the share screen, it's only showing me advanced sharing options. Who can share?
Cancel and try again, please.
Yeah, I'm trying to do that again. Okay, let me just.
For everyone following the training today, please mute yourself because we don't want to mute everyone. So you mute yourself and just follow. But if you think you are busy doing another thing, you can follow the lab on Facebook and create space for others that we want to follow and ask. We'll also be taking questions for those viewing through the Facebook Live. When we see the question, it will also reach to that of you. So you mute yourself and unmute when there is time for question and answer. But you use the chat box to put in your information if you want to ask, and you can drop a message before that of you coming. You can drop where you are actually from.
Excuse me.
You can drop your message in the chat box, telling all where you are joining from, and so we can know where our people are joining from to follow. Dr. Phil, you still finding it difficult?
Yeah, I think you have to make him a co-host. So can you try making
It's
a
the
co-host?
SP, right? The SP is up.
Yes,
Yeah, the
SP.
SP, but he's
SP.
not a co-host.
Remove co-host permission. He means he is already a co-host.
Yeah.
So, Dr. Kobe, you try to share, let's see. Because the same way he is co-host, that the same way you are co-host.
Yeah, I can share. I can share my screen. So I can share my screen. So just confirm if you've made him a co-host.
Then Dr. Phil, you can
Okay, let me try and share. Dr. Kwame, it's still the same page I sent to you, the advanced sharing option thing, you know. Okay. Now I'm able to share.
Now you're able to share. Okay, share.
Yeah.
Dr. Phil, any features now you can add me. I'm the Gideon Technology on WeChat.
All right, boss.
Okay, so guys, happy learning.
This is not what I want to share. Okay. So I think everyone can see my screen now, right? Hello. Dr. Kwame, is my screen visible to everyone?
Yeah,
Yes,
we
please.
can
I think you
can
have
say
the
thank you
floor.
so much.
Okay, thank you. Thank you all for joining this training section. It's a privilege to be here once again to take us through the basics of SPSS as a data analytics tool. My name is Philip, as Dr. Kwame rightly introduced me. So today's training, it's actually going to be very elementary. I will be looking at the basics of SPSS. Now, the first question is, what is SPSS? A lot of us today, when we write our methodology section, we still put something like, we have used the statistical packages for social sciences. That used to be correct. But as of 2009, when IBM bought over statistics, bought SPSS as a franchise, that name does not apply to SPSS any longer. So it would be of good practice for us to stop putting that. I used statistical packages for social sciences software. The name is now referred to as IBM SPSS Statistics. And it's been like that since 2009. Because now SPSS is no longer exclusively for social sciences. It's able to do a bit more than that. So that's very important, actually. I just feel I should bring that to our notice. For those of us writing thesis, don't put SPSS to be that. Why do we want to use SPSS? Among all the, let me use the word, non-programming statistical packages available, SPSS trumps them all because it has arguably the best user interface. It has a very good data handling capability, and it's very suitable for the non-technical user. And by that, I mean those who need statistical analysis at the beginning to intermediate levels. Now, the downsides are, now one thing about SPSS is that because of the user-friendly interface, it's easy to click and generate anything you want. So the tendency to generate many outputs, and then you end up having a lot of tables and chart and this, and that might look cumbersome to the average user, and being able to pick out the relevant one requires a relatively good statistical knowledge. Now, another thing is that, as I mentioned earlier, SPSS is likely more suitable for those who are not diving very deeply into statistical analysis, the social scientists, and so on and so forth. It's good for them. But when you would require like very robust analytic tests, the remedy to that is for you to use SPSS in conjunction with other advanced tools like Python and R. And the producers of this software, knowing that this limitation exists, have actually been able to provide what they call plugins, where you can actually plug in your Python and R in order to do more advanced analysis that you don't have in the SPSS interface. Now, the first thing we want to talk about now is the SPSS GUI. By GUI, I mean the graphic user interface. Graphic user interface. So I'm going to launch my SPSS now so that we can all have a look at what this is. Why is this thing here? Let me start from the beginning. Let me close this. Let me close this. Let me assume I want to launch my SPSS from the beginning. So I'll request that we all launch our SPSS. So if I put on my SPSS, I'm going to have something like this. It's loading. It's going to take a while. irrespective of the version you're using, you're going to have a similar interface. So you wait for it to load. When this window pops up, you don't need it. So you can just close this very window. My meeting is obstructing my... Hold on a second, please. The Zoom app is actually obstructing the top of my screen, so I'm not able to click what I want to click. Hold on a second, let me sort that. Okay, let me move it down. Yeah, I think this is better. So now when you launch your SPSS, you're going to have something like this, but you actually don't need this screen, so you can just close it. I see. So you can actually just close this like this. So can you see my screen? Hello, everyone. Can you see my screen, please?
Yes.
Yes,
Okay.
please.
Okay. So when you launch your SPSS, you're going to have this view. And below here, you see what we call the data view and the variable view. Data view, variable view. Data view, variable view. These two views are actually very, very important. And if you're able to comprehend how it works, then you don't have a problem using SPSS, because the most important thing in SPSS is for you to actually capture your data accurately. You don't need any technical knowledge to run the analysis. It's just click and play, like the way you type on your phone. So I'm going back to the slides. So back to the slides, the variable view, which I showed us right now, is actually where we define and modify the characteristics of our variables, such as the name of the data or the variable, the type, the weight, and the labels. We'll be taking a look at that very soon, so don't worry. Now, there are some naming conventions when it comes to naming variables in SPSS. Number one, when you're naming a variable in SPSS, spaces are not allowed. For instance, if I went back to my screen, let me see if I can split this into two, like this, and then I launch the SPSS alongside, and I close this like this also. I'm assuming we can see both my SPSS and the PPT. If we can, then very good. Now, what we're going to be looking at is this.
Yeah, both are visible.
We cannot see
Okay.
the writing clearly.
It's okay, I'll explain. Don't worry about that, okay? I'll explain.
Okay.
So now what I was talking about is that we want to name variables. And for us to name variables in SPSS, we activate the variable view. And for us to do that, all we have to do is to click on it. So if you can see my SPSS, we have data view first, variable view first. So you click on the variable view, it will be highlighted in blue. I don't know the color that yours is indicating. So if you got that, then it means you are in the variable view. Now, this is where we name our variables. So we're going to enter some data, a hypothetical data set we're going to be practicing with today. Let's assume I want to name a variable named gender. You can just click in it. It's very easy. Just click on the first column where you have the name indicator, name. Let's say we want to put gender. You type in gender. You just enter it. Very easy to enter data in SPSS. Now, spaces. Let's assume I want to enter a gender called level of education on the second row, and I say level of, there's a space, education. If I enter that, it's not going to be possible. Variable name contains an illegal character. Why? Because I have spaced the name. So SPSS does not allow this. But I'll show you how you can indicate the description of your variable very soon. So if I click OK, and then I cancel this and I go back to this place. If I really want to ensure that I capture that data as level of education, which I don't think it's necessary at this stage, I can do it like this. level underscore OF. That's if it's a must, I need to represent this variable with this name. Level of education. Like this. We can see it accepted this, right? Because there was no space. The underscore actually serves as a mitigating factor of restraining us from entering with space. So, but I felt this is too long, so I'm just going to put this as education. Just watch. Education. Then I enter it. Now, why have I decided not to put level of education? I'll show you very soon. That is because if you go along the columns, you have name, type, weight, decimals, label. Now, under the label, this is where you can describe the name of your variable. For instance, the first one is gender. I want to call this gender gender of respondent. Gender of respondent, like this. So that describes what gender is here. Now, education, I want to describe it as what? Level of what? Education. So that was why I said that it's not necessary for us to describe the name here, because you have a column, name label, where you can actually describe the name of the variable. So here I'm able to actually tell what I'm describing here by saying level of education. So we are still looking at the naming conventions in the variable view of SPSS. Now, each variable name must be unique, meaning you can't use gender here and gender here. So they must not be identical. Now, your variable name cannot be longer than 64 characters. Your variable name cannot be longer than 64 characters. And I think that's very easy enough. So that is the first part with the naming conventions. We'll come back to this later. For now, I'm going to open my PPT for us to continue. I'm going to open my PPT. Why can't I have this? Okay. Yeah, so if we are here, you can see my PPT clearly. So we've actually touched on this, no spaces. We can use underscores. And okay, another thing we can't do is that we can't start a variable name with a number or special character. What that means is this. Imagine I want to put a variable here and I decide to put 1 as a variable name. If I entered, it's going to tell me illegal first character. So you cannot start the naming of a variable using either a number or a special character. By a special character, we mean something like, let me say, at. Something like at. Oh, it's actually, okay, you can actually use some special characters. Can't start with number or special character. You can actually use some special characters. Sorry, I made a mistake in that slide. But you can't use numbers, but you can use special characters. So it's actually, you can use special characters, but not numbers. My error in this slide. Okay. Now, the next thing now is we want to look at the data view. We'll consider that later. But before then, before we actually enter data and look at what the data view tells us, the data view simply shows us the data we've captured using SPSS. We'll come back to that later. The most important thing in SPSS is measurement scales. If you don't indicate the measurement scales appropriately, then you can't run the relevant analysis. Because when you assign the wrong measurement scale to the wrong data type, then you'll be restricted on the type of analysis you can run. So probably this is a very, very important section of this whole training. So I would like us to pay very good attention to this. Now, any statistics book will tell you that we have 4 measurement scales: the nominal, the ordinal, the interval, and the ratio. The nominal, the ordinal, the interval, and the ratio. Please let us try and understand this very well because it is very important. Now, when you say nominal scale, what does that mean? Now, nominal scale simply refers to the grouping or categorization. Males and females, colors, white, blue, black, green, yellow, marital status, single, married, divorced, gender. Of course, in the gender, you can see I added male, female, and we live in 2024, so there are people who report to have other genders. So when you're designing your questionnaire, it is not a good practice to add others. So nominal refers to the categorization of our what? Quantities, as clearly explained. The next one is ordinal. From the word order, there is a grouping with meaningful order. There's a hierarchy. Take, for instance, level of education. Conventionally, someone with a bachelor's degree is considered to be academically higher than someone with a high school diploma. And someone with a master's degree is considered to be academically higher than someone with a bachelor's degree or a high school diploma. So that is why we say ordinal is for what? Ranking. There is a meaningful order. There is a meaningful hierarchy. Now, a very important part of this ordinal scale of measurement is what we call the Likert scale. Now, most times when we design our questionnaires, we use these psychometric scales. Can you indicate your level of agreement or disagreement to the following indicators? Strongly agree, disagree, neutral, and so on and so forth. So, Likert scale, which could either be 3, 5, 7-point Likert scale, falls under ordinal scale of measurement. So when you're capturing your Likert scale responses, please make sure to indicate that your measurement scale, which I'll show you in SPSS now, is actually an ordinal level of measurement. So we also look at something like socioeconomic status, like low income, middle income, and high income. So we've covered two types of measurement scales: the nominal, which only has to do with categorization and grouping, and then the ordinal, which actually gives us a meaningful order or hierarchy of measurement. Now, the remaining two are what we call the interval scale and the ratio scale. Now, when you say interval, the interval scale actually have other categories with equal intervals between them. I'll explain this better. They do not have a true 0 point, meaning 0 does not indicate the absence of the measured quantity, but rather a point on the scale. Take, for instance, we all went through the winter. Whenever the temperature is 0 degrees Celsius, does it mean that there is no temperature? No. We still feel the temperature. So 0 in interval does not indicate that there is no measurement or there is an absence of the quantity being measured. It's simply just a point on the scale. Take, for instance, another one, IQ scores. This is repeated. You cannot say because someone was tested and the person has 0 IQ, it means the person is completely senseless. Is that possible? No. There will always be a form of intelligence in someone, irrespective of how low the IQ is perceived to be. So the interval scale has no meaningful 0 or has no what we call true 0. Now, the last scale of measurement is what we call the ratio scale. Now, the ratio scale actually exhibits all the attributes of the interval scale, but in this instance, there is actually a true 0 point. And when we say there is 0 in ratio scale, it actually reflects the absence of the quantity being measured. Okay, let's take a very common example, money. It is possible to have 0 money. If you don't have money, you don't have money. 0 means no money. So that is true. Kilogram, that is weight. You can have 0 weight. So that's measured on ratio scale. But the good thing for us in SPS is that we don't have to bother so much about, is this one interval, is this one ratio? No, we don't have to bother ourselves with that, because SPSS actually groups both interval scale and ratio scale to be scale. So when we go back to the SPSS software, you're going to see that we don't have anything like interval, we don't have anything like ratio. SPSS combines both of them to be what? Scale. And usually scale variables are quantitative variables or continuous variables, usually. Quantitative and continuous. And usually our ordinal and nominal variables fall under, usually they fall under qualitative variables. So this is just the brief introduction to SPSS, and I think this is all we need at this stage. So what we're going to be doing now is I will input some data point, then we look at how we do all this measurement scale setting, and then we proceed to running some very descriptive analysis. So practical section 1, manually entering data in SPSS. Now, in this world of technology, we now capture our data using websites like Qualtrics and co. So we have our data in electronic forms in spreadsheets. So that will cover that under importing data. But then the traditional way, before the advent of online data collection, we do what we call manual entry. And that's how we are going to start this training, so that we'll have a very good grasp of how things work in SPSS. So I'm going to start with the manual one. So I'm going to launch the SPSS software again. And I would like all of us to open our SPSS and input the same data points I'm going to be inputting manually, so that we can set the scales and data labels and width and everything together. Please, have we all launched our SPSS? Hello?
Yeah.
Yes,
We are
Okay.
ready.
Yes.
Okay, once our SPSS is on, and you can see my own screen, now there's something missing here. Now, before you start entering data, in your questionnaire, you always say something like confidentiality of the respondent is assured, meaning you don't even know the respondent. So what we normally do is to assign a hypothetical number. We call it the ID or serial number. So assuming I've entered this already, but I forgot to enter the ID or the serial number of the respondent, you can go to the first row, right click on it like this. When you right click on it, you see copy, paste, clear, but you see insert variable. So I'm going to insert one variable, which goes to the top. Automatically, SPSS names it variable, wherever. But I want to name this my ID, respondent ID, or some people call it either ID or SN. Whichever one is okay with you, they are the same, serial number or ID. It's a hypothetical labeling for the respondent. So when I do that, I have the first row being ID, then the type is numeric. Now, if you click on this numeric, please click on it. You'll see 3 dots there. Click on the 3 dots. The pop-up window shows you numeric, comma, dot, and so on and so forth. Now, ideally, under normal conditions, we work with strings and numeric. String variables and numeric. String is when you have to type in, like their words you're capturing. But if you have used a questionnaire where you've assigned, let me say 1 equals male, 2 equals female, it is good practice to choose numeric because you're going to capture those data numerically. So that's that on that. Now, I want my ID to be numeric because it's going to be a number 1, 2, 3, 4, 5, 6, and so on for the respondent. Now, the width is how long the type is. So normally, ideally, 8 is okay, except you have very longer, depending on the length of what you're entering, but 8 is okay. And then decimals. Since I want my ID to be 1, 2, 3, 4, 5, 6 for the respondent, I don't need the decimal. So all you have to do is remove it. Click on it. You see an arrow. One is pointing down, the other one is going up. Just remove it. Take it to 0 because we don't need decimal there. What about gender? I want one for male, one for female. I don't need one point anything for gender, so you remove it. Education. Now I'm capturing my education as one for high school, 2 for this, 3 for that. I don't need it, so I can remove it. But before we start removing all that, let's create other variables. So come back to that after data imputation. Now I want us to impute another data here. After education, impute a variable called height. Height. And enter it. Why? What did I enter? It's telling me here, impute a variable called height. Okay. Then on the 5th row, impute a variable called, let me say, weight. Like this. So now we have 5 rows: ID, gender, education, height, and weight. Now we go back to my decimals. Ideally, someone's height could be, let me say in centimeters, could be something like 175 point something. Someone's weight could be, let me say, 75 kilograms point something. So it is okay for us to reserve decimal notifications here for these 2 variables. Now, conventionally, decimals are more applicable to quantitative or continuous variables. So we can retain this one. So now I can label this as height, let me say in centimeters. I can say weight in, let me say, should I say kilogram anyhow, or pounds, anyhow you want. Weight in pounds, yeah, something like this. So the first one here, the ID, I can just say serial number of respondent. Like this. So now we've covered name, type, weight, decimals, label. Now, the next one I want to consider, which is very, very important, is values. 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 Now, for the ID, what does value mean? For the ID, I don't need any values for it. But for the gender, I want to be able to differentiate between my males and females. So if you click on this cell and you click on the 3 dots here, it opens up a page, value labels. Now, I want to capture my data like this. 1 should represent males. So you can put 1 in the value, and then the label becomes what? Male. Then you click add. Then I go back again. I want 2 to represent female. Then I click add. 1 for male, 2 for female. That's how come you see this when data is being captured. After that, I'm just going to click on OK. See that? Good. Now, education. Let's assume we have 3 levels of education. Let's assume, it's an assumption, it's a hypothetical data we are generating. Let's say 1 is high school, and let's say 2 is BSc, and let's say 3 is a postgraduate. Let's call it PGD. So I want to capture my education as 1 for those who attended high school. I add it. 2 for those who actually had first degree, let's call it BSc. and 3 for those who have masters, PhD and above. So we call it PGD. Well, so when you add it, you have this. But for the height and the weight, we don't need any values for it. So you leave it. Now, the most important thing we need to consider now is we'll consider these missing variables later, but for now, let's just leave that. Now, the most important thing here now is our measure. The alignment is just how you want this to appear. If you want if you click on it, if you click left or right, it just where your entries are indicated. Now, if you go to measure, you can see unknown, 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 unknown. And this is where the fundamental knowledge of measurement skills comes in. Now, earlier we said gender falls under nominal. It is a category. And 1 here does not mean males are first, and 2 does not mean females are greater than males because they are having 2. No, it's just a category. It is a grouping. So I'm going to come here. My ID is actually a scale because it's just number, but we're not going to analyze the ID, so you can just leave it. Now, the gender is nominal because it's just a category. What about levels of education? It's a grouping. People with BSc are considered to be more educated than those with high school, and those with postgraduate education levels are considered to be. So there's a natural hierarchy. So that is what? Ordinal. So you set it to be ordinal. And then your height is a scale variable. Your weight is also a scale variable. Now, SPSS does not give us that stress of trying to differentiate if it's interval or if it's ratio. So we just choose scale, and we choose scale, and we enter it. This column is very, very important. If you don't choose the right measurement scale, you will be limited by the analysis you run. So you would always have to come back to indicate the right measurement scale before you can proceed. So please pay attention. So now we have everything sorted out for our 5 rows. Let's go to the data view and then impute some hypothetical data, and we'll play with the data. So let's go. When you open the data view, you can see from variable view, you have this. When you click on the data view, can you see you have your ID, your gender, your education. If this is not showing where you can open it, just like in Excel. So now let's enter some data. So let's say respondent number 1.
Hello, please, can you go back again? Please, can you go back again?
Go back to
a little bit before coming to this page.
the variable view here. Are you okay?
Okay, yes, you can continue.
Okay. So now we can go to the data view here. So we want to impute, please you impute as I impute. This data is purely hypothetical. So let's assume respondent number 1 is a male. And because I had coded my data to be 1 for male, 2 for female, I'm going to input 1. Can you see that as soon as I imputed 1 changed to what? Male. Now let's assume this person has the second level of education. Let's just put 2. I can't remember that was. Okay, so 2 is BSc. And let's just assume this person is, let me say, 67, wherever in height. Then what about the weight? Let's assume he is 128 pounds. Assumption. Now we go to number 2. Let's say this is 2. let's say this person is number 2, it changes to female. And let's say this person is highly educated, number 3, postgraduate. And let's say this person has a height of 70 and a weight of, let's say, 124 pounds. You enter like this. Please enter. We're going to run some basic analysis with this hypothetical data before we actually import a data file. So we can do that. 3, let me say 1, let me say 1, let me say 62, let me say 136, let's say 4, let's enter up to 10 data points so we can do something little with it. So 1 again.
Hello, sir. My own is not changing. It's just showing the number I'm entering. The one is not changing to
Exactly.
gender.
It's not
Not
changing.
changing
It's
to
okay.
gender, just like your
It's
own.
all right. Don't
Everything
worry.
is not
Don't worry.
changing.
I'll show you. Don't worry. If it's not changing,
at the top.
if it's not changing,
Yeah.
go to the top. Can you see there's like an arrow pointing down? Then one is going to say A and 1. Can you see this arrow?
Yes, you can see it.
Yeah. Now click on it.
Okay. It's changing now.
Did it change? So you can always
Yes,
toggle
yes, yes.
between them. 1,
Change now.
this. So it depends on where the one that has been activated. You see it now, right?
Yeah, change now. Yes, yes.
Yeah. So that's it. Any other question? Okay, if there's no question, we continue with the data imputation. So let's say we have respondent number 5. Remember, these are questionnaires. In a real world, when you collect your questionnaire on the paper questionnaire, the traditional way where you administer, this one here is questionnaire number 1. So when you actually pick the questionnaire up in those days, what we do is we name it 1 at the top. Now, why you do this is because when there is an error in data imputation, because you had written 1 on top of the first questionnaire you pick, you can always go back to that questionnaire that you've labeled 1 and correct the error in the data imputation. So in the real world, this 1 is respondent number 1, which corresponds to questionnaire number 1. So normally you just write 1 at the top of that questionnaire. Then you enter its content. Yeah. So the next one is, let's say we have 2. Let's do this quickly. Education, let's say we have 3, 2. So we have 70, 153. So we have 68, 144. So we have respondent number 6. 2. Level of education is 1. 68. 78, yeah. So we have 116. Question number 7. So we have 1, 3, 66, 122. Question number 8, 2, 2, 70. So we have 143. Question number 9. We're gonna stop very soon. So we have 2, 3. We have 66, 151. So we have let's see, 10, 1, 2, 65, 151. So this is how you enter data. Now I'm gonna leave out, I'm gonna put 11, 12, but I'm gonna leave out these 2 gender on purpose to show something when we run analysis. So I'm gonna leave this here. So we enter the other ones. Let's say 80. Oh no. This is 3. This is 160. Let's say, let me just make it let me make it 89. 118. So the last one, let's stop here. The last one, let's say 2, say 60, let me say 140. Yeah. So this is how you manually enter data. And it's exhausting in those days, you know, when we used to do this. Exhausting. You have to pick, if you have 1,000 questionnaires, imagine doing this. I remember you're going to have a lot of variables here. Many variables, plenty of them here. Now, this is very easy. Anyone can do this. Assuming you have a situation where, you know, we've all seen this kind of questions where somebody will say, tick as many as applicable. This is very important. How do you capture? Let's say someone says, okay, before then, let's go back to variable view. Leave the data view. Click on variable view. If you're on the variable view, let's assume we want to add a variable called level of agreement to the time of this SPSS training. So let's say we've administered a questionnaire to all of us and we say, on a scale of 1 to 5, where 1 equals strongly disagree, 2 is disagree, 3 is neutral, 4 is agree, and 5 is strongly agree. Indicate your level of agreement to 3 p.m. as a starting time for this training. Let's assume we want to add that variable to this data set. So I'm going to call it time agreement, AGG. And I'm going to label it level. I like making it short. The shorter the better. Agreement to SPSS time. So it's so easy to add variable in SPSS. Now, we mentioned that we want to indicate that 1 is that you strongly disagree to this time. So disagree, this is how you capture that in your you add it. Now 2, you disagree. 3, you're just there. You can call it neutral. It's okay, maybe anything goes. So you can call it neutral. Add it. 4, you can call it agree. 5, strongly agree. This is how you capture it. So after that, I just add it. Okay. So when you have Likert scale data in your questionnaire, this is how you capture it in SPSS manually. So that's that. Now I need to set, I don't need decimals because I don't need decimals for that because 1 is agree. I don't need 1.00 something to show that. Now, who can tell me what would be the measurement scale for this variable?
Ordinal.
Ordinal. Thank you very much. It's an ordinal level of measurement. I'm just trying to show us how we can capture the various types of data in SPSS. Now, a very common type of data that is also being used is what we call the multiple choice. Now, multiple choice is where you test someone. Let's ask a question. Let's say, indicate your decisions. Tick as many as applicable. Your reasons for joining this SPSS training. tick as many as applicable. You know, so when you ask a question like this, as many as possible, how do you capture that in SPSS? Okay, I think I have a, let's use this hypothetical example so that we can understand this very well. Oh, no. I don't want to save. If I minimize this, just save it. Okay, I can just save it anywhere because it's my data. If I minimize this and then I go to, I think I named the file called SPSS. Okay, I can't find that file now, but let me just show you how you do that. Just show you how you do that. Okay. Let's assume we have, let's call this multiple choice question. Multiple choice question. And the label is choose as many as applicable. So you're going to tick your level of agreement. Now, how you code this kind of responses? Let's assume we are asking people, tick as many as applicable, your reasons for joining this meeting. Tick as many as applicable, your reasons for joining this meeting. And then under that, you have 1, to run data analysis. 2, you have something like, let me say, to gain knowledge. Then you have 3, let me say, to teach others. I'm just making this up, to teach others. Then 4, let's say you have others. That's other reasons. Remember, the question is, tick as many as applicable, your reasons for joining this training section. And you've asked someone to tick as many as possible. And the first option you've given someone is to run data analysis. The second one is to gain knowledge. The third one is to teach others. And then, let me say number 4, others. Assuming I responded to this questionnaire and I have ticked option number 2 and I have ticked option number 4, meaning the only 2 applicable to me are number 2, to gain knowledge, and then number 4, others, wherever that could be. How do we capture that in SPSS? Now, all you have to do is go to your values. So if I tick a particular indicator, I'll call it 1 and label it yes. Then, if I did not tick a particular indicator, I'm going to call it 0. Then it's going to be elsewhere. Meaning 1 for yes and 0 elsewhere. Like this. So meaning if the person ticked 1, or whichever one the person ticked, whenever you're entering the data, you put what? 1. But if that particular indicator is not ticked, you choose what? 0. So if I went back to my data view, for instance, and then let's assume I, Philip, am respondent number 1. And then among the 4 indicators given to me to indicate why I have attended this, I've clicked option number 2 and 4. So when I'm entering this data, here, you will have to label each indicators separately in the variable view, like this. This has to be broken down into 4 different indicators. This particular question, it has to be broken down into 4 indicators. This is the general format to capture this indicator. Now, because I have 4, I'm going to come down here. Let's say I have reason 1. Run analysis. That's my first reason. All I have to do is sometimes you can just come here. Okay, let's do it manually so that we learn. So I can say 1 for yes, add 0 else where, like this. That's reason 1. Reason 2. Remember, I'm still under the same indicator. I come here. My second reason was gain knowledge. Knowledge. This is the same thing. 1 for yes, 1 for if someone chooses that. Then you say 0 else where. Then I add. Then reason 3, R3. Let me say teach others. I can just teach others. And I can say 1 for choosing that option. That's yes. And then 0 else where. Like this. Oh, what did I do? Did I mention? Okay. 0 elsewhere. Yeah, like this. Now reason 4. R4. So others. I call it others. So you're gonna have 1 for yes. 0 else where. So this is how you capture multiple response indicators in SPSS. If you've asked someone to tick as many as applicable, so for each of those indicators under that construct, you're going to form something like this for all of them. In this case, R1 stands for to run data analysis, R2 stands for to gain knowledge, R3 stands for to teach others, and R4 stands for other reasons. So what I define here technically wouldn't appear here. This would be in what we call code book. Yeah, technically this would not appear here. So only those indicators will be shown here. So after that, you come here. So let's say, as I agreed, I didn't agree to this, I put 0. And then we don't want decimal. So we go back to the variable view, remove decimals for all this, because the decimal doesn't make sense there. So we remove the decimals, we remove the decimals, we remove the decimals. You know? So let's go back to the variable view.
Hello, in the column, in the variable column, how does your column change? You can see changes in your column. In the variables.
I don't get you, please. I don't get you clearly. Can you
This
ask
variable,
again?
the column
Yeah.
section is changing. You're having 8, 8, 12 as against our own 8, 8.
This one?
No, the
The
column,
width?
column.
No,
After
column,
mixing, the column.
These are columns. I don't get it.
No,
This is
no.
No,
You mean after the missing
After the mixing,
various
yes.
column?
values missing columns.
values missing.
Yes, 8 column,
Is
yes.
it in the data view or
In variable view.
oh here.
You're having 12.
Okay.
Our own is 8 or 2.
8 or 2.
It's okay. It's the column width. So don't worry about that. Don't worry about. I mentioned leave the missing value and column. Those ones are not necessary. Don't worry about them for now. Okay. It's not going to affect anything. Yeah. Thank you. Okay. So we go back to the data view, and then I did indicated that if I was respondent number 1 and I have chosen option number 2 as to gain knowledge. So when I get here, I'm going to put 1 when I'm coding this 1. But because I didn't take this 0, I chose this, so 1. This is how you enter multiple response analysis. So let's say respondent number 2, tick as many as applicable. This person, respondent number 2, chose this, can choose everything, okay? Some people can tick everything. So in that case, everything will be 1, 1, all true. Someone can say 0 to this and tick every other thing. Yep, like this. So this is how you capture multiple response analysis in SPSS. So you have to capture each indicator and then you assign 0 to not ticking that and then 1 for ticking that. I think in the next 3 minutes, we'll go for a short break before we come back and do some descriptive analysis. So far, so good. We've learned the basics of capturing data in SPSS. First of all, we said we have a representative ID or serial number to capture the respondent or the questionnaire number you are on. And I did mention that if you are using paper questionnaire, this is a conventional practice. This one, you write it on top of the questionnaire because after data imputation and there's an error, let's say there is no height here or weight and you don't know which questionnaire that is. So when you put 1 here, you must tally it with the respondent number you are entering. That is the importance of this ID or serial number. Then you capture the gender. We talked about measurement scales. We said we have 4 types of measurement scales. The nominal, which has to do with grouping and categories, such as your gender, your color, and so on and so forth. Grouping of cars. Then we talked about the ordinal, which has a natural hierarchy, and the hierarchies actually make sense, like level of education, level of development, like low income, high income, and so on and so forth. Then we said that we have the interval and then the ratio scale. But luckily for us, SPSS combines both the interval and the ratio scales into what is called scale. So I will go for a 10 minutes break. When we come back, we'll do some exploratory data analysis. See you in 10 minutes. Thank you.
Yeah, hello people. So I think we can also have 10 minutes break while we wait for doctor to come back. So feel free to stretch your legs, take a cup of water, and then if you have any question when he comes back, we can take the questions before we continue. And if you think the pace is also too fast, please let us know so we would adjust a little. Okay.
I think our time is up and we're all welcome back to the second section of our training today. Someone asked an important question in the chat group. The person asked if, let me read that chat again, please. What was the question? The person said, JP said, what if the question is an open-ended question? How do you capture that in SPSS? What if the question is an open question? In this case, we call it an open-ended question, where the respondent is allowed to indicate his or her own answer. So in that case, this is what you do. Let's create a hypothetical variable to demonstrate that as well. Let's assume, let's say, I'm asking people to indicate their countries, but I didn't code it because obviously we have so many countries in the world and I can't say one, China, two, this, we have so many countries, so in that case, hypothetically, let's assume I want people to indicate their countries in the questionnaire. So I'm gonna call that variable here, let me say country. We are trying to create a scenario where you have an open-ended question where each respondent is expected to provide an answer. And I'm using country as an example because we have so many countries and you can't possibly list all of them and indicate and ask the respondent to indicate, especially when you're dealing with an international population. So in that case, when I enter the variable country, on the type, I'm going to remove this type and I'll make it string. So it's no longer going to be what? Numeric. It's going to be what? String. So I'll change the type to string to allow each respondent to provide an answer to the question. So I'm going to click OK. And of course, I don't need decimals for a string variable because they're going to type. But obviously, some countries are very long in their spelling, so it would be a wise idea to increase the width to as long as, let me say this should work. Yeah, that should be okay. So I can name this as a country of respondent or respondent country. Anyhow, just the shorter, the better. The more descriptive your labels, the better. Country of respondent. So in this case, there is no value, I'm not going to say 1 equals to anything, 2 equals to anything. I'm just going to keep a string. So, of course, the measure should be nominal because I'm not classifying them into any hierarchy. So I'm going to leave it there. So when I go back to my data view, I have a variable called country. Let's say I want to enter this and I'm from Ghana. I'm just going to type Ghana. Someone else is from, let me say, USA. Just going to leave USA. Someone else is from, let me say, India. I'm going to leave India. Someone else is from, let me say, Laos. And so on and so forth. So these are you capture open-ended questions where the respondent is allowed to input his or her information. I think that is clear. JP, I hope I've answered your question. Are we all here?
Yes, sir. We
Hello?
too.
Yes,
Okay.
we're here.
Okay. No, JP asked the question and I've used an example to answer. So I want to be sure that he got the solution to his question, you know. Okay, so that being said, so this is how you capture open-ended questions. So now that we have this hypothetical data, let's play with the data. Let's run some analysis. The essence of all this blah 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 is for us to be able to
Can I
generate
ask a question?
statistical. Yeah, you can.
Okay, thank you so much. I want to ask a question about the Likert scale, the measurement
Likert scale,
Likert
okay.
scale. Yeah.
Yeah.
So sometimes it can be like 3, sometimes it can be like 5, and sometimes it can be like 7. So why these are like 3, 5, 7, something like that?
Okay. Now you must first of all, let's take it from the premise that, you know, Likert scales are indicators for measuring unobservable construct. First of all, they are psychometric scales like satisfaction, happiness, loyalty, and so on and so forth. Now, it is advisable to use Likert scales that are above 3 because you're able to capture more sensitivity in the responses. So depending on your field, if you're dealing in fields that require a lot of perception, if you're measuring perception, it is advisable to use at least 5. Because the longer the Likert scale, the more you're able to, because the more you're able to capture the sensitivity of the responses. But I don't think 3 is acceptable these days. 5 and above is okay. 5 if you're just in a normal social science context, but 7 if you're actually dealing with a very, very subjective and sensitive issue. Does that make sense?
Is it possible to use more than 7?
Well, in the field of research, everything is possible, but I haven't seen more than that. But everything is possible if you can justify it. But ideally, 5 to 7 is what I've seen.
Thank you so much. And
yeah,
what if we don't use like ID?
I think this is more of another section of research, which is probably taking our time from this. So I think you can inbox me or inbox Dr. Kwame and we talk about that privately, okay?
Okay.
Thank you. So that we don't spend the time on that. Thank you very much. So now we have this. Let's run some interesting analysis. Let's say I want to see the number of males and females I have in my data. SPSS makes it easy. Just go to analyze. Go to the top. The top ribbon, you can see analyze. Now, under this analyze, we have report, descriptives, different types of statistical analysis. But we're going to start with the simple ones, descriptive statistics. I've captured my data. Now I want to see. Now, the first one here is frequency, descriptives, and explore. We're going to practice with these 3. Now, it is advisable to use frequencies when you have the when you want the flexibility to choose. So let's run the analysis. Go to analyze. If you click analyze, descriptives, frequencies. Click on frequencies. When you click on frequencies, you'll see that there is a pop-up menu where you're supposed to insert your variables. So all you have to do is select the variable. You can click on it. Let's say I'm clicking on gender of respondent, and then you move it in here with the center arrow. If you want to return it, you can bring it back. Another way of doing that is to just grab it. You hold it and drop it in like this. So you click on it, you hold it down, you drag it in. And you can also move multiple variables at the same time. Let's say I want to move gender and level of education and height. So I'm just going to open them, select them as you would normally in everything. And I move all of them. So that's how you select the variables you want to analyze. So this time around, I'm going to do it one after the other. I'm moving gender. I select level of education. I move it in. I select height. I move it in. I select weight and I move it in. So we have these 4 variables and we want to compute descriptive statistics on them. We're going to do it many times just to see what's happening. So if I choose statistics, okay, let me leave the statistics out. So just click on OK. Click on OK. When you click on OK, you can see so many outputs for each of the variables. Now, as someone is talking at the background, please, can you mute yourself, please? Okay, so if you have this output for the frequencies, you can see that for each of the variables, gender of respondent, level of education, weight in centimeter, weight in pounds. Now, we have valid. For the gender, we have 10 valid, and we have 2 missing, which I did purposely. I'll show you why. Now, level of education, 12. We have 12 valid responses, so there's no missing variable here. Now, when you come to the gender of respondent, we have 5 males, 5 females. That's evenly distributed. Now, look at something here. Excuse me, I have some code. So, you can see we have 2 percentages. One is percent, and the other one is valid percent. Now, the percent column captures the total number of respondents in the data set, which is 12. So it's accounting for the missing values, 16.7. But the valid percent represents the actual number of males and females who responded to my questionnaire. Now, I would recommend that when you're reporting, it is of good practice to report your valid percentages unless there is a strong reason to account for the missing responses. I take that again. When you're writing your report, it is better practice to report your valid percentages and leave out these missing values. Unless there is what? A very important reason to include them in your report, then you can do so. So the same thing has been done for level of education. High school, we have 16.7, degree holders 14.1%, PGD 41.7%, and so we can see, interesting, right? So we have all the descriptives here. Now we can do better than this. We can do better. Let's assume I want to see all this in a chart. I want to see all this in a chart. I already have these tables. You don't need to close this window. You just go to the top, click on Analyze again. Then Descriptive Statistics, then Frequencies. Now, all I have to do, because I have already generated frequency tables, you can untick this, Display Frequency Tables, untick it. Okay. Now, I want chart. So I go here. I want bar chart. So let me choose bar chart. And I want it to be in percentages. So I want bar chart, for instance. I'll show you something. So if I click continue, okay. Now look at something. It's going to generate a new set of output. You see? Gender of respondent. Male, female, we can estimate the percentages here, 50-50, as we saw earlier in the table. Now, level of education. Of course, there are also distinct groups, which is okay. We have this, we have this, we have this. I'll show you how to format this later, but don't worry. Now, let's go to this. Height in centimeters. Using a bar chart to represent or to capture a continuous variable is not, it's not a good statistics. We can do better than this. So the essence of this is to show us that for categorical variables, bar charts, sometimes bar chart, depends on the classification, is good. But when it comes to continuous variables like weight, sales, and so on and so forth, bar charts are not a good representative. So now let's run another analysis. Meaning you have to run multiple analyses depending on the type of variable you have. So for instance, gender and level of education, this is okay. I can copy this and paste in my report. It's easy, you just copy it. Now you highlight it, then you copy. Yeah, you copy. You copy chat, then you just go to your Microsoft Word and you paste. But before then, you can actually do a lot with this. You can format it to show all the variables and everything, but I'm not going into that now. We'll do that later, but I just wanted to learn how to plot before we go into formatting and order, okay? Now, I did mention that it is not appropriate to plot height and weight on bar chart. So let's go back to analyze. We'll go to descriptives, the same frequencies. Now, I go back to my chart. Now, I want histograms. Now, I want to show the normal distribution curve. So I choose histogram, show normal distribution curve, then I go for the same set of variables. Okay, and I wait. Now, if you do this for categorical variables, it is beautiful nonsense. It doesn't make any sense to plot histogram for categorical variables. We have the gender has a mean of 1.5, doesn't communicate any statistics. With a standard deviation of 0.5, doesn't communicate any statistics. So you don't plot a histogram for categorical variables. So this is not appropriate. And that was why I said one of the weaknesses of SPSS is that it generates a lot of output. It is easy to run the analysis, very easy to run the what? Analysis. But you need a bit of statistical knowledge to draw the appropriate interpretation. Yeah. So this you don't need in this very analysis. But when you go to the histogram, you can see, you can also edit it and then close these gaps. Normally, you have to close these gaps, which I'll show you later, but I just want to ensure that you understand the different types of chart you can use for which variable. So, height, weight, this is okay. This is good for them. So depending on what you're doing, you have to run multiple analyses to actually pick out the best output for each variable. Just the same way you cannot choose bar chart for the weight and height, you cannot choose histogram for gender and level of education. So that is that on that. Now, the next thing we can do is, let's assume what we are seeing so far is for the whole sample. What if I want to see, like, compare the height of males and females or the weight of males and females? Another descriptive statistics we can actually run is to compare the mean height by gender. So let's run another analysis. I'm going to close this because I don't need it. Let's say I want to see the height of males and the height of females in my sample, or the weight of males and the weight of females in my sample. I can actually do this. Analyze. In this case, I'm not going to go to descriptives. I'm coming down to compare means. So if I come here, then I click on means. Let's say I just want to see for height, because height is dependent variable. Then I want to group them by what? Gender. Now, gender is actually what we refer to as what's it called? Quasi-independent variables here, because they weren't actually assigned, but we just leave it at that for now. So let's say I want to compare this. So if I click on this, where's the output? The output is covered. I'm coming. Yeah. Yeah. Now let's look at this. Here I'm trying to compare the height of males and females. So we can see the gender of respondent and then the height in centimeter. So we see in this hypothetical sample, remember this is hypothetical because in an ideal world, we might expect that males will on the average be taller than females in a large enough sample. Let me put it that way, in a large enough sample. So because this sample is so small, we can have any output. So here we can see that the height by gender shows that males on the average are 66 centimeters, and then with a standard deviation of 2.9, and then females are this. So we can do this for any group. Okay, let's do similar thing for the level of education. We can go compare means, come here. Now I want to remove this. And I want to replace this height with weight. I want to see how people with different levels of education, I want to compare it. So come here, click on OK. So we see. So here we are comparing the weights of people with different levels of education. So on the average, people with BSc weigh about 141.2 pounds, with the standard deviation of these, high school these and these. So this is how we compare. It's also a descriptive statistics. You just want to see your data. You want to see who is saying what and what is the average of what. So you can use this simple compare means analysis to just see. Okay, so let's assume I don't want to go through this process, but I want to see my gender distribution in graphs. And that way we can actually plot descriptive statistics graph is to use the chart builder. So here, if you go to just beside to the right of analyze, you can see graphs. If you click on graphs and you click on chart builder, we assume we define our variables properly. So just click yes. So you're going to have this. This canvas will open up. And when this canvas opens, you see the names of your variables here. Then you see the gallery showing you the types of chart you can actually plot. And in this case, I want to plot a bar chart for the level of education. So all you have to do is come here and choose simple bar chart. Then you drag it here. Come here. Choose any, you can use component bar chart, clustered bar chart, anyone you want, but for simplicity's sake, I'm starting with simple bar chart. So you just pick it and drag it and drop it in here. Now, after that, I want to plot my level of education. So I can drop it here. See? So easy. SPSS gives you the chart automatically, and you can actually choose what to see. and what not to see. If you want to see count, you want to see percentages, you know. If you want to see percentages, you use percentages. Yeah. So you can choose what you want. Count simply means frequency, percentage, and whatever you want, or the values and whatever. So you choose what you want to be represented. So I'm just showing us different ways we can generate charts in our SPSS. So this is one way to actually build chart. Let's say another one is I want to create another one. So I want histogram, and I drop this here. It changes. So I want to plot the histogram of the weight. See, you just drop it. Then you format. When you format it, you can get all the other elements like the normal distribution curve and everything. So, but I'm just showing us how we can easily. So let's say I don't want this. Let's say I want a pie chart. I can pick it and drop it here. And I want a pie chart for the level of agreement to our time of study. So if I slice it by here, this is what you get. You know, we have 1, 2, 3, 4, 5. So you can just, when you format it, you get all the, which we're going to do later, but just get familiar with plotting different types of charts. So it's just a matter of clicking the variable and dropping it, and then you get the kind of chart you want. So that's that on that. So that's that on Explore. But there's another way to run descriptive analysis in SPSS, and that is using the, remember the first time we were doing descriptive statistics, go to frequencies, and we analyze. And I did mention that you use the frequency option when you want more flexibility, like you want to choose what you want to have. But if you want basic statistics, go to the describe. They pretty much do the same thing, but the describe option also allows you to create what we call standardized values. Now, standardized values are also known as z-scores. Now, for those of us who did our basic statistics, there's this part where we say the data point X minus mu, the sample mean over standard deviation. And then we get Z equals to that value. That's what we call the standardized value. So if you want to access these z-scores or standardized values, you cannot generate this using the frequency approach. Meaning if I click analyze, descriptives, frequencies, you see, I cannot get the standardized values here. It's not there. So if I want to generate z-scores for my data point, for instance, the best approach is to use analyze, descriptives, statistics. Now, let's choose only two. Let's choose height and weight. If I move these two variables here, I'm going to click on Save Standardized Values as Variables, and we'll see what will happen to our data set. Now, options, what do I want? If you click on this, I want standard deviation, I want the minimum height, the maximum height, the standard error, the range, the variance. If I have standard deviation, I don't think I need variance. So you choose based on what you want. You want the distribution, the skewness, whatever you want. You just, depending on your needs, you know, the range, and so on and so forth. So you continue. Now, if I click this, I click this, I want us to notice something. Let's go back to the data set, the original data set. If you've done what I did now using the descriptive approach, you'll see that we have two new columns added to our data set. You see that we have two new columns added to our data set. And the first one is called the Z height. Second one is called the Z weight. Of course, we cannot compute z-scores for qualitative variables or nominal variables like gender. No, it's not statistically accurate. Even the SPSS will generate outcomes for you, but it doesn't make statistical sense. So what does the z-score tells us? Now the z-score, when it's negative, it's telling you that this data point falls below the sample mean when it's negative. But when it's positive, it's telling you that, well, it's above the sample mean. We're just exploring. So a negative z-score shows that this very data point falls below the sample mean, and a positive one means that, well, it's above the what? The sample, slightly above the sample mean. So that's just like a generic explanation of, we'll get to all this later when we go to more advanced analysis. So this is what you get here. So that's one. Now, another thing we need to do again is we can use the descriptive approach to run descriptive analysis using the approach explore method. Now, the explore method enables you to do a little bit more than the frequencies and the descriptives approach. So let's do something with this. If you come to analyze, descriptives, explore. We've touched on frequencies and descriptives. So now I want to do explore. If I click on this variable, we're going to do this twice. First of all, let's move the height and the weight to the dependent list. And then if we go to statistics, let's check outlier. You can see here we have more options. Outliers, if you want plot, but I think we've looked at plot, system and leaf histogram. If you want this, okay. Normality plus with test, you can check a lot, you know. So you continue, and so we want both statistics and plot. If you don't want plot, you can just choose statistics, but we want both since we are exploring. So if I click OK, aha. So the explore option gives you like a lot of statistics on the variables, you see? Okay, let's take a look at something. For instance, this is descriptives for height and variables, and weight. I have a confidence interval, median, variance, standard deviation, any interquartile range, skewness, kurtosis. So it depends on what you're looking for. The explore approach actually gives you more statistics. So this for weight, and it even adds more extreme values. That's outliers, you know. Then a test of normality to test if you can see. If you want to test if your data is normally distributed, which is actually a fundamental assumption for more parametric analysis, you can use this, the explore option. You test for normality and you see if it's significant. Then you can see they're both less than 0.05, so you can see they're normally distributed. The histogram. So this stem and leaf plot. We're not dealing with interpretations today. We are just dealing with how to run this analysis. So you can see we even have a normal QQ plot of the height. This one is when it's the trend, when you remove the trend element. So you can see when you use the explore approach, you can get more output for each variable. And that was why I said earlier that SPSS has a tendency to generate numerous output, and you may need statistical education to determine which to include in your report. Yeah, so this is what the explore option does. But now we can even do better, you know? Let's assume we want to split all these outcomes by categorical variables. Let's say by gender. You know, this is for the whole sample. Let's say I want to see all this based on gender categories. So let's go back to the analyze, descriptives, explore. Now, I'm not going to change anything here. all I'm going to do is to introduce a factor element here, which is my gender or level of education. So if I insert this, let's run the analysis again. If you click on this, bam. Now we have a different set of output, very similar to the previous one, but here everything is now presented in terms of gender. So we have for the descriptives, we have height for males, height for females. We have weight for males, weight for females. So we have the descriptives by gender grouping. You see? So if we want to draw descriptive inferences on the gender distribution of our sample size, we can just look at it and talk about something. Now, every other output is also disintegrated into female and male respondents, so we have this here. And the test of normality is also, can you see something that when we tested for the whole sample, both the height and the weight was normally distributed. But now when we splitted it, we can see that the significance values are quite larger than the conventional priori values of 0.05. And then what could actually account for this is because of the low sample size. So we can't really draw any meaningful inference on this, but I'm just showing us as a way of running the analysis. So this is how you do this. So this is for males, you can do for females. Remember, all this for only height. All this for only height. The stem and leaf plot, this is for male, this is for female. The KQ plot, this is for male, this is for female. So using the explore approach gives you more control over the type of analysis you run. And you can actually, so let's do this for, let me say, level of education. I'm not going to save this output. Let's repeat the same analysis for level of education. So I'm going to use analyze, descriptives, explore, and I'm going to retain the same dependent variables, but I want to remove the gender. So now I want to put my level of education as my grouping variable. And then I'll leave every other thing constant. I don't want to change anything. Okay, let's assume I don't want statistics. I want only plot. So I'm just going to have this. Give it a bit of time. It's going to run the analysis and you have the output. So now, oh no, this is not my output. This is not the output. This is, okay. Is it the output? Yeah. This is the output. Yeah, this is the output. This is the output. Yeah. So we can see this is the grouping of the weight and height variables by level of education. So you can see high school, BSc, postgraduate diploma, then test of normality for each category of the data set. So the data set has been splitted into this. The histogram for high school. Please hold on. Hello, sorry. The administrative staff of my school came around. So, okay, so this is what you get. This is what you get. So when you split by level of education, you generate the same output for all subgroups of the data set, grouped by level of education. Yeah, so that's that. We've considered how to generate z-scores, and we've actually done a lot. We still have about 10 minutes, so we can quickly look at another descriptive statistics, which most of us really like. We can quickly look at correlation analysis. Now, correlation analysis simply measures the movement between two variables. They are moving in a positive or negative direction. A positive ones means that there's a direct correlation between the two variables. As one increases, the other one also increases. A negative value means that as one increases, the other one is decreasing, and correlation coefficients ranges between -1 to +1. 0 means no correlation between the variables, and the closer a variable is to 1 in either direction, the stronger the relationship between these two variables. For continuous data and quantitative data, it is often recommended to run the Pearson's correlation coefficient, while for ordinal data set, the Spearman's correlation coefficient is often the best approach. So let's assume we want to run a correlation analysis between height and weight of our respondent. Height and weight of our respondent. So we still go to analyze. SPSS is so easy. Then we look for correlate. You see? Analyze, correlate. We are looking at bivariate correlation. So we click bivariate correlation. I want to check the correlation between height and weight. If I move this in, you can see we have Pearson here, Candace, and then Spearman. Now, the choice of correlation coefficient is dependent on the type of data you have. If you have a continuous data set like height, weight, you use Pearson. If you have ordinal data set, most time people abuse this Pearson's correlation coefficient. They just run it for any type of data set. But if your data is not continuous, Spearman rank correlation coefficient is more suitable, or I would recommend Spearman rank correlation coefficient. So let's run this. Now we can see the output here. See? The correlation between height and weight. Here we have height and height is 1, of course, perfect correlation. Height and weight, you have -2.17. Remember, this is the hypothetical data. Does it mean that the taller somebody is, the lower the height? Well, this is hypothetical data, remember? So we can't really draw inference based on this data, you know? Of course, the correlation between height and weight is equal to the correlation between weight and height. So we'll have symmetric values here in these two. So you see, weight and weight is 1, weight and weight is 1. Weight and height is -2.1, same thing as height and weight. So this is how you run correlation coefficient. But we can actually introduce a nominal variable into this. So in that case, we call it a biserial correlation. I'm just showing us how we get familiar with the whole interface. We'll do better in subsequent meetings. So let's say I want to introduce gender into this correlation. So I go to correlate, bivariate, then I click gender. So it becomes a biserial correlation. Let's just run it. If you run this, gender has been introduced. Gender has been introduced. So what's the correlation between gender and height? 0.51, 0.54, but the significant value of 0.10 makes it not to be statistically significant, but then it's quite a relatively strong correlation. Then we look at gender and weight, -3 points. Negative 0.31. This is point. Okay, so this is how you introduce your variables for correlation analysis. But remember, the type of correlation coefficient you use is dependent on your variable type. So this is that on this. And then we need to be careful how we interpret correlations in our report, although we'll cover this in more detailed analysis. On this note, I would like to pause and take a few questions for the remaining 5 minutes. So the floor is open for questions.
Good day to you. Thank you very much for the insightful lecture. So my question basically is on if you are to check the correlation between education now and an ordinary data like all these like Likert scale data. So which type of correlation means do you suggest that one can use? Is it Pearson?
No, I will suggest Spearman. I'll suggest Spearman. Correlation coefficient. Let's say I want to analyze correlate by variate. And let's say you want to check the level of education, and let's have a level of agreement here, you know? So I would suggest Spearman rank correlation coefficient and reserve Pearson for strictly quantitative data. It still gives you, you know? So you get something like this. It's not even significant, so we don't even have output here. Cannot be computed because at least one of the variables is constant. Okay, yeah, I think our data set is not good, but ideally use Spearman correlation coefficient. The data set is not suitable for this analysis, okay? It's a hypothetical data set I generated. So Spearman will be the ideal one.
Yeah, thank you.
There's a question.
Any other question?
There's a question that says how to interpret correlation result.
Okay. Ideally, I think I did that, but let me go over that again. Correlation coefficient ranges between -1 to +1. So if you have a number line, on a number line, you're moving from -1 on the left-hand side, the center is 0, to +1. Now, a correlation coefficient of 0 means there is no relationship between the two variables. If I move towards the left-hand side and I have x and y, and let me say I have -0.6 as a correlation coefficient between two variables, it means that these two variables are moving opposite direction. We can call it inverse relationship, meaning increase in one variable leads to a decrease in the other one. But if the correlation coefficient is positive, let me say positive 0.6, it means, let's say for instance, under normal conditions, your level of education and your income level is supposed to move in the same direction, meaning the higher the level of education you have, the higher your income. So if you have 0.6 as correlation coefficient between them, it means as your income level increases, it means alternatively to your educational level is increasing. So that's how you interpret correlation coefficient. But please, correlation does not mean causality. We'll cover all that later. It's just a relationship. Any other question? Hello?
Yeah, hello, Dr. Phil. I think we
Hello.
have 1 minute, but then, okay, I think someone is talking.
Yeah, hello, doctor.
Sorry.
My
Yes.
question is, based on the result output we got now on the relationship, correlation.
Yeah.
Depending on which value we can interpret. Can you go back once to the result in the table?
I think I didn't save mine. So, but okay, let me check. Let me check if I No, okay, but I think let me quickly run it again. Here, by variate. Let me say I'm running for width and height so that we can have something to interpret. And I'm using Pearson's. Okay. So I have an output. Okay. So what's your question? Can you ask your specific question? Can you see my table?
Yes. Now for report.
Yeah.
Our report. In the table correlation coefficient, for example, for Pearson raw correlation, 1 is there, -3 is there. Which one we can use?
Yeah. Now, you know, we are not looking for the correlation. You know, this one here is the correlation between height and height, which is not of interest to us. It's always a perfect correlation. So what we are looking for is, if I'm interested in the correlation between height and weight, then the value I'm looking at is -0.362. Can you see that?
Yeah. So the relationship is negative.
Based on this, so based on this hypothetical data, it is not a real data, we are having a negative correlation between height and weight, which implies that as my height is increasing, weight should be decreasing, and vice versa. As weight is increasing, height should be decreasing. Do you get it?
Yeah.
So you look at the interconstruct correlations, but then for you to interpret this statistically, you have to look at the significant values. You can see, normally we test at the primary value of 0.05. We can see that this 0.24 is greater than what? 0.05, which means that statistically, this correlation between height and weight is not significant. But as I said, this data is hypothetical, so we are just using it to practice, okay? So over to you, Dr. Kwame. I think I've taken 2 minutes of our time.
Hello, Doc. Sorry, please. A quick one.
Yeah.
Can I continue? So
yeah, you can quickly ask your question.
You said something around correlation doesn't mean causality, but basically showing a relationship between data. So my question is, if it doesn't mean causality, what importance does this have in the output of a result, like in the output of a result, probably when showing the relationship between the dependent and independent variable, like of what importance does it have? Like, I just want to know.
Let's assume you want to run a regression analysis. You know, there's what we call spurious correlation, when there's a relationship between two non-comparable things. So first of all, if you're running a regression analysis where you're trying to test for causality or something, you would expect that the two variables you're comparing, there is at least a measure of relationship between them. But we don't want too high correlation, because if the correlation is too high, let's say 0.99, it simply means that those two variables you're trying to compare are identically the same. So ideally, correlation has to be established for causality to happen. But we'll cover that in subsequent sections of this training. So I would encourage you to join, then you'll get a better understanding of the whole thing. Please, you get me?
Thank you. Thank you very much.
Yeah. I think we'll end it here for today. Dr. Kwame, over to you, please. Okay. Dr. Kwame is not responding, so thank you all for attending. Come next week, we'll run better analysis, and then we'll start with how to interpret and which outputs to look at. Thank you so much for attending.
Sorry, your name again on the platform, your name.
In which of the
which
platform?
Which
I think Phil. Phil. Yeah.
Okay.
Dr. Phil, just with Dr. Kwame is already coming back in. I think you have a network problem. Then we can end this.
All right.
Dr. Kwame, are you here now?
So sorry, everyone. I think I was logged out for a moment. Okay, so thank you so much, Dr. Phil, for having us. We appreciate the 2 hours impact you've made, and then we hope next week we'll be seeing you. So on behalf of the entire student body who are here to learn from you, we want to say a big thank you, and we wish you the very best and be in good health. Now to our fellow students here, thank you for making it to the session. It's a privilege, and I think we've had a very smooth one, less distraction, which is good. So we can keep it up and then we'll be able to enjoy the recordings. The recordings will be made available on YouTube, so please just get the recorded version so that you can practice. So until we see you next week, do have a good week ahead, and then we'll see you same time next week. Okay, bye.
Okay,
Bye.
everyone. For those of you following on Facebook, we say bye-bye and thank you for your time and thanks for following. Bye-bye, everyone.
Okay, thank you so much.
Thank you. Bye.
Thank you.